Welcome to Wisdom Academy. Today we'll be looking at energy, physics, part 1, chapter 7. Physics, part 1, chapter 7. We'll be looking at chapter 8 or so, thereabout. Okay. So this is part 1 for work, energy, and power. But we're starting from energy. Okay. So this is energy, part 1. We have part 1, part 2, part 3 for energy, and then we do work and power. Is that okay? Now let's take a look at the energy stores. What's energy? Energy is the characteristics that an object has that is stored or that can be transferred. Something an object has inside it. Something that enables an object to do work. Something that gives the object the ability to do some work. So it's something that is stored in an object or something the object can transfer. So this property that an object has that can be stored or transferred is called energy. That can be stored or transferred is called energy. Now, energy must be transferred to an object to perform work. Anytime we want to do work, we must transfer energy to the object. If you want to climb a staircase, when you climb a staircase, work is done. So energy must have been used up. Energy must have been transferred in doing work. Okay, energy is also used to heat up things. Okay, thermal energy. Energy is used to heat up things, and energy must be converted or transferred to objects in order for work to be done. Now, the unit of energy, the SI unit of energy, is joules. So we can define energy as the ability or capacity to do work. Energy is the ability or capacity to do work. Energy is the what? The ability or the capacity to do work. So that thing we have that enables us to be able to do work, that is transferred for us to do work, is called energy. Okay, without energy we cannot climb staircase, we cannot do running, we cannot do athletic things, we cannot do gymnastics, we cannot walk about from one place to another, we cannot even copy our notes, we cannot do anything, we can't learn. Without energy we cannot learn, we cannot perform tasks. So that characteristic, that thing that helps you, that is stored in you, that helps you to do work is called energy. In human being, the energy comes from chemical energy, from the food. Energy comes from the food we eat. Energy comes from the food we eat. Okay, the food contains what we call the chemical energy. Sometimes chemical energy are found in different places like batteries and so on and so forth, batteries of things that power things up. So energy is in different form. We're going to describe the forms of energy. Now let's go to systems. We have different systems in physics, right? Energy is described as part of a system, the ecosystem, right? Energy is part of the ecosystem. First, it comes in form of chemical energy and can be converted to different forms of energy. This chemical energy can be converted to other forms of energy. Now, how do we define a system? A system in physics is defined as an object or group of objects, okay? A system in physics we define as an object or group of objects. Now, defining the system is a way of narrowing down the parameters to focus on what we want, what is important to us, and what we observe in our environment, right? So a system could be as large as the whole universe, could be as large as a country alone, could be as large as a continent. So it depends on what you represent. Could just be an organization or institution. Okay, so a system depends on what you're looking at. Okay, so that's why we say the ecosystem. Which of the ecosystem are we looking at? Are we looking at the mechanical ecosystem, electrical electronics ecosystem, AI ecosystem? So energy is in all of these systems. Energy is in various systems and it depends on what we are looking at. Now, when a system is in equilibrium, nothing changes and so nothing happens. Why? Why is it when a system is in equilibrium nothing changes? Because both sides are equal. Both sides are equal. The energy of the reactor is the same as the energy of the product. So nothing changes and nothing happens. So when there is a change to a system, it means energy has been transferred. When it's in equilibrium, meaning no net energy is transferred. Net energy equal to zero. Okay, no energy gain in one side or the other side. So when something is in equilibrium, the algebraic sum of the energy on the left side equal to the algebraic sum of the energy on the right side. So there is no net energy. Net energy equal to 0, or the resultant energy equal to 0. So there is no resultant energy. But when the system changes, then what it means is that there is energy transfer to either side of the reaction or to either side of the system. When there is a change, energy has been transferred to either the forward side or the backward side. Let's take a look at an example of a system. Okay, now before we move further, let's take a look at our tutorial. Is that okay?
This video is on the topic of energy stores and energy transfers. Everything that happens in the universe involves an energy transfer. Whenever there is a change in a system, energy is transferred. When the pendulum swings, energy is transferred from the kinetic store to the gravitational potential store, and back to the kinetic store, and then back to the gravitational potential store, and so on. The total amount of energy in the system is constant, but the energy is being transferred from store to store within the system. Energy is stored in objects in different energy stores. Moving objects have energy in their kinetic store. When they stop moving, energy is transferred away from the object. When objects are raised through a gravitational field, energy is transferred to their gravitational potential store. When the object falls, energy is transferred away from the object. Energy is stored in the chemical bonds of substances. When chemical reactions occur, energy is transferred to or away from the chemical energy store of the system. When an object is squashed or stretched, this is sometimes also called strain, energy is transferred to its elastic potential store. When the object is released, energy is transferred away from the object. Energy is stored in the electrostatic energy store of charged particles. When those charged particles are attracted to or repelled by other charged particles, energy is transferred. Energy is stored in the magnetic energy store of magnets and magnetic materials. When magnets are attracted to or repelled by other magnets, energy is transferred. Energy is stored in the nuclear energy store of atomic nuclei. When nuclei are split in nuclear fission, energy is transferred. And when nuclei are joined in nuclear fusion, energy is transferred. Energy is also stored in the thermal energy store of objects due to their temperature. When an object is heated, energy is transferred to the thermal store of the object. When an object is cooled, energy is transferred away from the thermal store of the object. You do need to remember all the names of the energy stores and be able to apply them to the context given in a question. Let's take a look at an example exam question. A battery-powered drone at rest on the ground flies vertically upwards and hovers in the air. State the energy transfers taking place, and it's worth 3 marks. Let's make sure we understand the scenario. The drone is initially at rest on the ground. At rest means that it's stationary, it's not moving. The system here is defined as the drone flying vertically upwards from its stationary position and hovering there. So we need to identify the energy transfers taking place just for that piece of motion. The 3 marks are an indication that we're looking to name 3 energy stores. The command word here is state. It's tempting to think that that means you just have to name the 3 energy stores, but be careful. The question is state the energy transfers taking place. In any transfer, there is a store that energy is being transferred from and a store that energy is being transferred to. So, firstly, where is the energy being transferred from? Energy is transferred from the chemical store of the battery in the drone. That's the first mark. The words that are underlined in a mark scheme mean that you have to say that bit in exactly that way to get the mark. So, where is that energy being transferred to? Well, the drone starts moving, so that's the kinetic store, and that's the second mark. What's next? The drone flies vertically upwards, so it's gaining height. Therefore, energy is transferred to its gravitational potential store, and that's the third mark. Notice in this example that the energy transfers taking place are between different stores in the same object, the drone. And that's okay. Sometimes students think it must be wrong if the energy transfer is not from object to object, but it totally can be. It all depends on the context. Let's have a look at another example where students often think it must be wrong. A person holds a mug of hot coffee. They feel their hands getting warmer. State the energy transfers taking place, and this time it's 2 marks. So again we ask, where is the energy being transferred from? Well, it's the hot coffee, right? The coffee is in the mug, so there must be an energy transfer going on to cause the mug to heat up, and then there must be another energy transfer that causes the hands to heat up. So energy is transferred from the thermal store of the coffee, that's the first mark, to the thermal store of the mug, that's the second mark, to the thermal store of the hands, that's another mark. Sometimes mark schemes are structured so that you can gain the marks by saying any combination from several answers. So here you would get both marks for saying any 2 of these 3 things. Notice in this question how the energy stores are all the same. This is another example of when students think it must be wrong, but it's not. Energy is being transferred between the same energy store, the thermal store, but the energy is being transferred from object to object to object. In summary, energy is transferred between energy stores. That could be different stores in the same object, or the same stores in different objects, or even different stores in different objects. When answering questions, make sure you always say where the energy is being transferred from and where it is being transferred to. Don't forget to check out all our other fantastic revision resources here at Save My Exams.
Okay, so we've seen how energy can be transferred from one energy store to another energy store, right? We see how energy can be transferred from one energy store to another energy store. Now let's quickly take a look at this second one. Okay, so let's see the transfer of energy, the pathways, how energy is being transferred.
This video is on the topic of energy transfer pathways. Energy is stored in objects in different energy stores. When changes occur, energy is transferred from store to store. Energy stores are kinetic, gravitational potential, chemical, elastic potential, electrostatic, magnetic, nuclear, and thermal. Energy transfer pathways describe how energy is transferred from store to store. There are 4 energy transfer pathways you need to know. When a force acts over a distance, energy is transferred mechanically. The mechanical work done is equal to the energy transferred. When charge flows around a circuit, energy is transferred electrically from the cell to the components. The electrical work done is equal to the energy transferred. Energy is transferred by heat from hotter objects to colder ones. Energetic particles in the hot coffee transfer energy by heating to the thermal store of the cooler mug. As the mug heats up, energy is transferred by heating from the thermal store of the mug to the thermal store of the colder hands. Energy transfers can be broadly split into 2 categories, working and heating. If any type of electromagnetic radiation is involved, then the transfer pathway is by radiation. This includes visible light, which is the most common example. You do need to know the energy transfer pathways and understand how to apply them to different contexts. However, past exam questions have been more likely to assess your knowledge of energy stores when it comes to naming parts of the energy transfer process. Let's look at an example of an energy transfer. A woman pulls on a rope which lifts a bucket of water from a well. What are the energy transfers taking place here? As the woman pulls on the rope, she is moving. Therefore, she has energy in her kinetic store. The result of her motion is that the bucket gains height. It is lifted up the well. The bucket gains energy in its gravitational potential store. The woman has applied a force over a distance by pulling on the rope, so the transfer pathway is mechanical. Therefore, energy from the kinetic store of the woman is transferred mechanically to to the gravitational potential store of the bucket. Let's take a look at an example exam question. A simple circuit includes a cell and a filament lump connected in series by copper wires. State 2 energy transfer pathways for the energy emitted by the bulb, and it's for 2 marks. The resistance in a filament wire causes heating to the extent that light is emitted from the bulb. Therefore, energy is transferred from the thermal store of the filament bulb to the thermal store of the surroundings by heating. That's the first mark. This energy transfer explains the resistance in the filament wire. Remember that when a word or phrase is underlined in a mark scheme, you need to say it in exactly that way to get the mark. Energy is also transferred from the thermal store of the bulb to the thermal store of the surroundings by radiation. That's for the second mark. So in summary, energy is transferred from store to store via different energy transfer pathways. Energy can be transferred mechanically, by a force acting over a distance, electrically by moving charges such as electrons in a circuit, by heating from a hotter object to a colder one, or by radiation, which is usually visible light. Don't forget to check out all our other fantastic revision resources here at SaveMath.
Okay, so we've seen the 4 ways by which energy can be transferred. Okay, the 4 pathways by which energy can be transferred from their store, right? So quickly, we've already took a look at briefly. We have to just move through this quickly. So we say an object on this has a potential energy. Okay, stationary object here has a potential store, right? Potential energy store. Here, when the object is falling, okay, if it's in a height, it becomes gravitational potential, and it's falling, the energy will be converted from the gravitational potential store to kinetic store. Okay, now let's quickly talk about their stores. Energy stores. Energy is stored in objects in different energy stores. Okay, now let's take a look at energy. Kinetic. Moving objects have energy in their kinetic store. Right? Every moving object has energy in their kinetic store. If an object is stationary, it has energy in the potential store. Gravitational. Objects gain energy in their gravitational potential store. Okay? When they are lifted up, you lift the object up, it's up like the one on top of the table. Okay, it has energy in this gravitational potential store. The energy in this apple put on the table, because it's in a height, it has energy in gravitational potential store. Now, elastic objects have energy in their elastic potential store if they are stretched. So if you take a rubber band, if you stretch it, then you have energy in the elastic energy in their elastic potential store. The energy is in their elastic potential store, or not only when you stretch them, when you squash them or bend them also. So the energy is stored in their elastic potential store. For magnetic objects, magnetic materials that interact with each other have energy in their magnetic store. So we have all these are the different forms of energy. Okay, indirectly we're teaching you the different forms of energy, meaning there's magnetic form of energy, elastic form of energy, gravitational potential form of energy, kinetic energy, and so on and so forth. So the elastic store objects with a charge, like the electrons and protons, interacting with one another, have energy in their elastic electrostatic store. Sorry, this is electrostatic. Okay, so energy in form of charge. Okay, charge that is not moving is called electrostatic store. So any charge, the energy it has is in form of electrostatic store. Then in case of chemical reaction transfer energy into or away from a substance from their chemical store. For example, in the case of a car battery, the energy it has is from its chemical store. So the chemical energy is going to transfer is from its chemical store. The food we have, the energy it contains is from its chemical store. And the energy the food transfer to our body is from its chemical store to other forms of energy. In terms of nuclear, atomic nuclei release energy from their nuclear store. Release energy from their nuclear store during any nuclear reaction, right? In terms of thermal, all objects have energy in their thermal store. all hot objects, to be precise. All hot objects have energy in their thermal store. So they transfer this energy from their thermal store to their environment. The hotter the object, the more energy it has in its thermal store. So hotter object has more thermal energy than colder object. Now let's take a look at energy transfer, which has been discussed in our tutorial. Energy is transferred between stores through different energy transfer pathway. There are about 4 transfer pathways by which energy from mechanical energy can be transferred to electric energy. Mechanical energy can be transferred to electric energy. Electrical energy can be transferred to thermal energy. Chemical energy can be transferred. So there are these different forms of energy. There are 4 pathways by which energy can be transferred. The first one, energy transfer pathway, is called mechanical. This mechanical is a means by which energy can be transferred from its store. For example, if you apply a force on an object to move it through a distance, you have applied the mechanical energy. A stationary object that starts to move, it gets kinetic energy. So what it means is that the pathway by which this energy is transferred from potential energy to kinetic energy is called mechanical pathway. So there are 4 pathways by which energy can be transferred. By mechanical pathway, the second one by electrical pathway, when charge flows in a circuit. So energy is transferred from its battery in form of chemical energy to electrical energy. That means, or by that method by which energy is transferred from chemical store into electrical store in form of current flow in its wire, is known as electrical energy or electrical pathway. Energy can also be transferred by heating. For example, in terms of thermal energy, thermal store energy can be transferred from one thermal store to another thermal store. For example, if you have hot coffee in a cup, the hot coffee can transfer its thermal energy from its thermal store of the coffee to the thermal store of the cup, and from the thermal cup of the cup to the thermal store of the hand. So this method is by heating. Then the fourth one, pathway of transferring energy, is by radiation. The heat from the sun reaches us from radiation. So the heat energy is transferred through electromagnetic wave. Here, wave is being used. Okay, electromagnetic wave is being used. So these are the 4 ways by which energy can be transferred. Okay, so we have explained that. Now let's move on quickly. We have what we call the energy transfer by heating. Okay, you can see if you have a hot tea or a hot coffee in this mug, and you put your hand on the outside of the mug, the energy from the heat first is transferred. Energy from the thermal store of the coffee is first transferred to the thermal store of the cup. And then from the thermal store of the cup, the energy is transferred to the thermal store of the hand. Okay? So that's how the energy is being transferred by heating. Is that okay? Now let's take a look at this question. Describe the energy transfer in the following scenario. A battery powering a torch. The energy in a battery is a chemical energy. So the energy is transferred from the chemical store of the battery to the light store of the torch, right? Then we have a Fourier object. A Fourier object, energy is transferred from the gravitational store of the object to the kinetic store of the object as its force from a height. Okay, so these are the system. It's a battery is powering a torch. The system is defined as a battery and a torch. Therefore, energy began in the chemical store of the cell of the battery. So energy will start from the chemical store, like we've established, of the store. And then we say step 2 is determine the store that energy is transferred to within the parameters described by the defined system. When the circuit is closed, the bulb lights up. Therefore, energy is transferred to the thermal store. Okay, we can measure the thermal store of the bulb. Since energy is transferred and it lights up the bulb. Energy is then transferred from the bulb to the surrounding, to the thermal store of the surrounding. But this is not described in the parameter in the system, so it was not mentioned. So we can just mention the one that is mentioned. Energy from the battery is transferred from the chemical store of the battery to the thermal store of the bulb that lights up, and the energy is transferred by the flow of charge around the circuit. Therefore, the pathway is electrical. So here you are just mentioning the pathway with which the energy is transferred. The fourth one is that energy is transferred electrically from the chemical store of the battery to the thermal store of the bulb. So energy is transferred electrically. This is the method of transfer. The method is transferred electrically from the chemical store of the battery to the thermal store of the bulb. Is that okay? Now we go to Part B. Part B is to determine the store that energy is being transferred away from within the parameter described by the defined system. A falling object. Okay? In order to fall, the object must be raised to a certain height, right? Therefore, it has energy in the gravitational potential store. Okay? So, meaning energy will be transferred from the gravitational potential store since it's falling from a height. Now, then, as the object falls, it's moving. So, it will be transferred to its chemical store. So, the object is moving. It means the energy from the gravitational potential store is transferred to the chemical store. Right? The third one are the pathway. The pathway. For objects to fall, a resultant force must act on the object, right? And the force is the weight. The force of the we are talking about that is acting is the weight of the object. And it acts on it through a distance. The height is the distance, so it's a mechanical transfer pathway. This is a mechanical pathway. So we can say energy is transferred from the gravitational store to the kinetic store of an object via the mechanical pathway. So these are the terminology we use to describe the law of conservation of energy, how energy is being transferred from one form to another. So thank you for joining us in this part 2 of our class. Thank you. See you in our next video.